Hi. In this set of lectures, we're going to talk about randomness. We're talking about random variables and how sometimes outcomes that we see in the real world depend on our ability and also on a little bit of luck. We're also going to talk about something called random walks. And these are processes where the cumulative value of something depends on a sequence of random variables. So the amount of sales that a firm has depends on its sales each period. We can think of those each period sales as being random variables. Those are going to be what we call random walks. So here's a brief outline of what we're going to study. We're going to start out by just talking about what we mean by randomness, just a random variable. And then from that, we're going to construct a really simple model that involves skill and luck. So if you think about the outcome of some process, it's going to depend on our ability or our skill and also a little bit on luck. And then we can use that model to try and discern, when we look at someone who's successful, how much of their success can we attribute to them being really good and how much of their success should we attribute to them just being, well, lucky. So let's take a couple examples. So John Steinbeck and Jesse Owens. These are two extremely successful people. Historically, they're both considered, masters in what they did. So was Steinbeck good, or did he just happen to be lucky? Or was Owens good, or was Owens lucky? Now it's hard to imagine Owens was lucky because it's just a foot race. So you'd think that therefore it's the fastest person is going to win, and that's mostly skill. And for Steinbeck, you could say, well, it takes a lot of skill to write, the text that he wrote, and that he was also skillful. Well, it's true, both were skillful, but both also benefited from a little bit of luck, and we'll see why when we construct our model. Now, after we've done this sort of straightforward skill and luck model, we're going to move on to something called a random walk model. Now, random walk models work as follows. You're just sitting at a point, and then you take a step up or down, then you take another step, and then you just keep taking steps and randomly walking. So we're going to start with a binary random walk model, where each step is either +1 or -1. And then we're going to move on to a normal random walk model. Now each step is just going to be of random size, and that random size is going to come from that bell curve that we used before. Remember the bell curve from the central limit theorem? Our step size will come from that normal distribution. Now when we do the normal random walk, we're going to use this to begin a discussion of something called the efficient market hypothesis. And this is the hypothesis that in the stock market, price movements, after we detrend sort of the growth of the economy, are just going to be random. We'll see whether in fact that seems to be true. So after we do the binary random walk and the normal random walk, we'll move on and do one final model, which is a finite memory random walk. And the way this works is your value only depends on your last 5 or 6 or 7 random variables. So instead of having a walk that just sort of goes forever, you've got a value that just depends on random variables for each of the last 5 or 6 periods. Okay, so let's get started. This is going to be sort of a really fun, lighthearted set of lectures. Nothing's very complicated, but there's a lot to think about. There's a lot of really interesting things that are kind of come up when we start thinking about the effect that randomness has on outcomes. All right, thanks.